So here's part C of number 4 from the 2014 A, B, and BC exam. And I already plotted these values just to kind of save a little time in the video here. But in part C, it says at time t equals 2, train A is positions 300 meters east of the origin station. Train is moving to the east. Write an expression involving an integral that gives the position of the train in meters from the origin station at time t equals 12. So we know the position at t equals 2 is 300 meters east of the origin station. We need to tack on to this how much the position of the object, in this case the position of the train, changes from 2 to 12. I almost fell into a trap there. I accidentally almost said 0 to 12, but we know the position at 2, so we need to tack on to that how much the position changes from 2 to 12 by integrating the rate of change of position, which is velocity. So if we could do this integral, and I guess to have the notation be exactly like how it's presented in the table here, I'd have to integrate v sub a of t from 2 to 12 to figure out how much the position changes between this time, and then take into account where it started. It asks us to do a trapezoidal sum with 3 subintervals indicated by the data in the table to approximate the position at time t equals 12. And that's where we're going to do some drawing into the little graph that I've started over here already. So if we get a little bit of space down at the bottom of this, we want to do a trapezoidal sum. We don't care about anything to the left of that vertical line. We want to figure out about how much the train's position changed from 2 to 5. So that's going to amount to us finding the area of that trapezoid. About how much did the train's position change on the interval from 5 to 8? Now, this is kind of goofy because it's actually not a trapezoid. It's a triangle that's above the x-axis and then another triangle that's below the x-axis. The nice thing here is that the trapezoid's area formula is going to do all the work for us, and we're going to be able to account for the fact that some of this is positive, some of this is negative by just using the formula for the area of a trapezoid. And then along the last interval from 8 to 12, we would want to figure out what the area of this trapezoid is, because that would be how much the train has gone to the left or to the west. So our trapezoidal sum is going to look something like this. We're going to have 300 plus the formula for the area of a trapezoid is the average of the parallel sides. Well, this side measures positive 100, that'd be v of 2, plus this side, which would be v of 5, and that I believe is 40. The average of those two parallel sides is going to be 140 divided by 2, and then times the distance between them, which is just going to be 3. And then we're going to have to add to that the average of these parallel sides. So I have this parallel side and this parallel side. Sorry, this looks a little sloppy there. So this is going to be v of 5, and then plus v of 8, and I believe v of 8 from the table is negative 120. And then over 2, so the average of those sides, and then times the distance between, and it goes from 5 to 8 along the x-axis or the t-axis, so that's going to be 3 again, and then plus the area of one more trapezoid, and the height here is v of 8, which is negative 120, plus the height here, which is negative 150, v of 12, divided by 2, and then times the distance between those parallel sides, and the distance between those is going to be 4. We go from 8 to 12 along the t-axis here. So now it's just a matter of doing some arithmetic and answering appropriately. So if we simplify each of these, we're looking at this is going to be 140 divided by 2, so that's going to be 70 times 3. So we're looking at 300 plus 210. This is going to be negative 80 in the top. Negative 80 divided by 2 should give you negative 40. So it's going to be minus 120 on that interval. And then on the interval from 8 to 12, we're estimating that the train's position changes by whatever the value of this is. Now we can simplify this a little bit, so I'm going to divide that by 2, divide that by 2. If you do the math in the numerator here, you end up with negative 270. Right, that's going to be negative 270 times 2. And negative 270 times 2, I think, is going to leave you at negative 540. So if you go ahead and combine these positive pieces, that'll get you to 510. If you combine these negative pieces, that'll take you to, what, negative 660. And then 510 minus 660 is going to give you negative 150. So what is the position of the train at time t equals 12? Well, the fact that this is negative tells us that the train, which is train A here, train A is 150 meters west of the station. Right? If we're east of the station, we're assuming that that's positive. Right? We were 300 meters east to start with, so that was a positive value. The fact that this is negative just indicates that now we end up west of the station when it's all said and done.